This is a chapter 11 and 12 review for intermediate algebra. I'll leave it on the screen for about 30 seconds or so on each problem. This is how I suggest working these problems. This is problem number 1, chapter 11. This is problem 2, chapter 11, using quadratic formula. Remember, multiply and get rid of your fractions. Then make sure it's set equal to 0. And then work through your quadratic formula. The work is shown here. Number 3 is an equation with fractions in it. When you've got fractions in an equation, always factor the denominators. Then multiply by the common denominator. It cancels all the denominators. Then notice what's left. Multiply together the left side and the right side if there's any multiplication. Then combine like terms and set equal to 0. And then this, we use the quadratic formula. Number 5 doesn't seem like a lot of people were understanding this. X times x minus 3 times x plus 4 greater than or equal to 0. You get 0, 3, and negative 4 by setting those factors equal to 0. Those are your important points. So negative 3 is the least value. So that breaks the number line from negative infinity to negative 3. Negative 4, not negative 3. Negative infinity to negative 4. Then from negative 4 to 0. From 0 to 3. And from 3 to infinity. You take a number out of any of those, and all of those intervals to see if it works when you put it back in the original inequality. First interval, something to the left of negative 4, such as negative 5. We get a negative number when we put negative 5 in for all the x's. We get a negative number, not greater than 0. Then a number between negative 4 and 0. I used negative 2. When we put it in, we came out with a positive number. So yes, that's greater than 0. Then we went the interval between 0 and 3. I chose 2, and we put it in, came out as a negative number. So it is not greater than 0. Then the last interval, I chose the number 5 between 3 and infinity, put it in, 5 gave me a positive number. So the last interval from 3 to infinity worked, and the interval from negative 4 to 0 worked. And that's how you write your answer, shown there. Number 6, same type of thing, except it is a fraction. X plus 3 over x minus 2. Set those equal to 0. The first one, negative 3. Second one, 2. So they give you an interval from negative infinity to negative 3, from negative 3 to 2, and from 2 to infinity. You pick a number out in the first interval. I picked negative 4 because it was left of negative 3. Put it in, gave me a positive number. So that's not less than 0. Then I went to the next interval. I chose 0 because it was between negative 3 and 2. Put it in for the x's, gave me a negative number. That is less than 0. So that interval did work. Then I went to the last interval, 2 to infinity. Chose the number 3. 3 put it in, gave me a positive number. So that's not less than 0. So the only interval that worked was negative 3 to 2. Now, there's a bracket around negative 3 because of the equal sign on the bottom. You can have negative 3 plus 3 in the numerator. That is 0. 0 is okay in the numerator. But there's a parenthesis around the 2, because if you put 2 in the equation, you are dividing by 0, and you cannot divide by 0 no matter what. So bracket negative 3, comma, 2 is your interval. Number 7a, a parabola in standard form. Notice these steps. Need x-intercept. You need your vertex and label your vertex. You need your y-intercept. And you need your domain and your range. And you need your graph. And you need a table. Notice I showed how you could put those numbers in a calculator and find the y values. Notice on my vertex I had the number 4, so the x coordinates I put in are on each side of it, 3 and 5, and then 2 and 6. That was a parabola in standard form. Same thing if it is in general form, like this one is here. General form, no parentheses. So we put negative b over 2a to find the x coordinate of the vertex. Negative 3 over 2 times 1, so negative 3 over 2. So negative 3 halves, and then put negative 3 halves in for your x's like that. You come up with negative 6.25. You put it in your calculator exactly like that. And then that's negative 1.5. So I went on each side of negative 1.5. Negative 1 and negative 2. That's how you put it into the calculator. Then I went with 0 and negative 3. Found my y-coordinates. I graphed a parabola. To find the x-intercept on this parabola here that's in general form, factor or quadratic formula. Set 0 equal to x squared plus 3x minus 4. The f of x becomes 0. Then factor, so negative 4 and 1. The y-intercept is, of course, found by putting 0 in for all the x's. The domain, and then the range. The range is the lowest y-coordinate, negative 6.25 here, the vertex, up to infinity. Number 9 and 10. Number 9, factoring, shown there. All the steps. Number 10, I found that a lot of people on the right side just tried to square x minus 1 and forgot x minus 1 times x minus 1. You had to use FOIL. So you got x squared minus 2x plus 1. So many people forgot that and missed this problem. And this is how you do this. And both 2 and 1 do work when you put them back in and check it. I was wrong on some of your papers. Number 11, factor also, as shown here. And then x to the 1/3 means cube root of x. So cube root of x equals 2, cube root of x equals 1. So you cube both of those to get your answers, 8 and 1. Number 12 is the square root theorem. One variable in the equation, so we take square root of both sides. Square root of x plus 2 squared is x plus 2. Square root of the 7 is plus or minus square root of 7. So negative 2 plus or minus square root of 7. Then we went on to chapter 12, the ones we did. Write the inverse. Step 1, put y in for f of x. Step 2, switch around x and y. Step 3 and 4 is doing the algebra to get the y by itself. Then step 5 is just writing out the answer. F with a raised negative 1, parentheses x. Number 2 is just switching around those ordered pairs to write the inverse. Number 4, it's very important to remember, log to the base x of 16 equals 2. So that's x squared equals 16 as an exponent. So x is 4. Next one, log to the base 3 of 9 equals x is 3 to the x equals 9. And so 3 to the x equals 3 squared, so x is 2. The last one, log to the base 3 of x equals 3, so 3 cubed equals x, so 27. Then, to write this as a single log, number 5, 3 log to the base x of 5 minus 2 log to the base x of 5. There's other ways of doing this, but so that you can do each problem like this, first move the numbers out in front of the log back as exponents. Okay, as shown. Then 5 cubed is 125, 5 squared is 25. Since you're subtracting logs, that means you can put them together as a single log by division, as shown there. And then 25 into 125 is 5. Log to the base x of 5 is your answer. Number 8, you simply push the log button, 324 afterwards, and hit enter on most calculators. Okay, round off at 4 decimal places. Number 8b, you hit natural log and then 0.3171, put it in, and round off at 4 decimal places. There's some older calculators where you got to put the number in first, then the natural log. Number 9, log of x equals 3.6. No base was written, so that means log to the base 10 of x equals 3.6. So then 10 to the 3.6 equals x. That's your exact answer. Then you put 10 in your calculator, and then either with a caret key or a widely x, you put 3.6 in, and you get 3,981.0717. Natural log is log to the base e, is what natural log means. So, natural log of x equals 6.1. So log to the base e of x equals 6.1. So e to the 6.1 equals x. On your calculator, to get e showing on most calculators, you go second, natural log, and that'll get an e showing. And then you've got the e showing, then you put 6.1 and hit enter, and you get that answer. Some of the older calculators, you've got to go 6.1 first, and then second, natural log, the older calculators. Find out which one works to give you that answer. That concludes the reviews of the problems we did for Chapter 11 and 12.